Hi there. Thanks for joining us again. This is Space Nuts. My name is Andrew Dunkley. It's great to have your company. We're going to talk about a lot of things today, and one of them is the Artemis program. Now, we did talk about it very recently because things had changed. The Artemis 2 launch was set back, and it looks like they're actually going to take the Artemis 2 rocket back to the assembly building now. And they're not anticipating an Artemis 2 launch to send humans around the moon and back until at least April. But that's not what we're going to talk about. We'll explain that shortly. We're going to look at the new Cranium Nebula. This one sounds quite unbelievable. A brain in space? Could be. And the center of our galaxy has been mapped in detail. What's it look like? We will tell you on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Joining us once again is Professor Fred Watson, astronomer at large. Hi, Fred.
Hello, Andrew. Good to see you back from your sojourn.
Yes. I won't dwell on it too much. I'm sure people have seen the photos on Facebook if they cared to look on my page. I didn't put them on the Space Nuts page, but we went to Borneo for a couple of weeks and we saw some amazing wildlife, orangutan, sun bears, proboscis monkeys, civets. You know about the civet. They eat the coffee berry and poo out the bean, and then they collect the beans and turn them into coffee. Yeah, we saw some of those. Didn't try the coffee. What else? Oh, macaque monkeys. I even managed 18 holes at a rather nice resort golf course, and I paid the price for that because it was a pretty ordinary game, but I enjoyed the course. Beautiful. Although the greens in Dubbo are better than theirs.
Oh, there you go.
Much better. It's our superintendent was very pleased to hear when I saw him the other day. But yeah, incredible country. I think, I don't know if you can see the map behind me, Fred. See that?
I can, yes.
Yeah, that is the map of the Sandakan Death March. In World War II, Australian and English military personnel that had been captured by the Japanese were sent to Borneo to build an airport. And when it looked like the war was lost to Japan, they were ordered to kill all prisoners, and they force-marched 1,800 Australians from Sandakan to a place called Ranau in northern Borneo. Of those 1,800, 6 survived. It's a terrible tragedy. It's Australia's worst atrocity in terms of war. And not many people know about it. They know all about Gallipoli. They know all about some of the major battles of World War I and World War II. The Rats of Tobruk. It all goes down in folklore, but this is probably one of the most forgotten elements of Australian military history, and I would encourage people to go and read about it. I knew about it, but it's not well publicised, and I think it's a tragedy that we tend to put this stuff at the back of our minds, and should never be forgotten what happened over there. So we've basically on the tour followed the route of the Death March, not intentionally. It was just the way the road went, but went to the memorials and read all the names, hundreds and hundreds of names. The British suffered similarly. There were 600 British that were captured and basically left to die. It was just horrible, Fred, horrible. But the wildlife and the rainforests and the rivers and the people, magnificent. Highly recommend Borneo. Highly recommend it. Now, you were up late last night, weren't you?
I was, yeah. There was, because of the total eclipse of the moon, which I know you didn't get to see because you had 8/8 cloud in Dubbo. I know that because the Anglo-Australian telescope, not very far away from you, got no observations last night of any kind. But in Sydney, we've had cloudy weather for weeks, but the clouds broke. So we saw the eclipse. And that was Geordie, of course, that just chimed in there. But we actually have Geordie's sister staying with us for a little while. This is going to probably for the next few weeks, we'll have the terrible duo. They're more or less identical. One's a little bit fatter than the other. I won't mention which is which, but and so she arrived, Rosie arrived today. But that's nothing to do with the eclipse. We did see the blood moon. It was a total eclipse of the moon, so that the moon was well immersed in the shadow of the Earth. We had about an hour of totality, and during that time, the clouds came and went a bit, but we got a really good view of that blood moon phenomenon caused by scattering of light from the Earth's atmosphere, scattering of sunlight. Yeah, so it was good, but it was, as you've just said, a late night, and I'm just catching up. Basically.
Yeah, fair enough. Yeah, it's quite a spectacle, a blood moon. I'm sorry I missed it, but you can't help the weather. Which reminds me, we also had to deal with flooding at the end of the monsoon while we were overseas. So that was fun, driving through floodwaters. They wouldn't let you do that in Australia, but we weren't in Australia, were we? So, yeah. We should get down to it, Fred. There's a lot to talk about, and our first subject is yet again the Artemis missions. And I mentioned at the beginning that Artemis 2's been put back in the shed and probably won't launch those astronauts until at least April. But we are now talking about Artemis 3. Now, this was the mission that was slated for initially 2027, then pushed back to probably 2028. To put people on the moon. There's been several changes. It looks like they won't be doing that, and they might not be using SpaceX the way things are shaping up.
That's right. So this was an announcement last week at the time we're recording. And you're quite right. What has happened is that there's been a major update to the Artemis program with an extra mission slotted in. So Artemis 3, exactly as you've said, was originally going to be the lunar landing mission sometime after 2027. But what NASA has done is inserted another mission, which is now Artemis 3, which will not land on the moon. It will be a spacecraft that will simply go into Earth orbit. And what it will do is essentially replicate, in a sense, what Apollo 9 did after the Apollo 8 mission. It's to check that you can rendezvous with the equipment, you can do the necessary steps that need to be taken in space, which have not yet been tried and tested, because Artemis 2 will simply involve the Orion capsule containing the 4 astronauts. What that will do is it will accelerate up to the 11 kilometers per second needing to get to the moon, go around the moon and then come back again without any of the kind of technical details involved with, first of all, refueling spacecraft in space. That's one of the things that's part of the Artemis program, but also doing the rendezvous and turning spacecraft around and things of that sort. It's a bit like in the Apollo missions where you had to turn the lunar module around to dock with the crew module, with the basically the crew capsule. So all of that is now being slotted into Artemis 3, with the landing itself actually forecast for Artemis 4. And one of the reasons for this is the fact that there is still a lot of work to do on the landing vehicle. Now, back in the day, some years ago, NASA contracted both SpaceX and Blue Origin, the two companies led by the 2 billionaires, Elon Musk and Jeff Bezos. Those two companies were tasked with developing a crew lander vehicle to land on the moon. The favored version was Elon Musk's Starship, the top end of a Starship, which was originally going to be the Artemis 3 lander. Now the landing has been pushed back to Artemis 4, but the gate is now still open for the Bezos company to further develop its own lunar landing module, which has been under test for quite a while and is, so in a sense, is a competitor to SpaceX. So the two programs are running side by side, and NASA will eventually have to make a choice as to which one they go with. If I may, there's a very nice quote from NASA Associate Administrator, a very senior person in NASA, who says, "We are looking back to the wisdom of the folks that designed Apollo. The entire sequence of Artemis flights needs to represent a step-by-step build-up of capability, with each step bringing us closer to our ability to perform the landing missions. Each step needs to be big enough to make progress, but not so big that we take unnecessary risk given previous learnings. Therefore, we want to fly the landing missions in as close to the same Earth ascent configuration as possible, which means using an upper stage and pad system as close to the Block 1 configuration as possible." That's the basic Space Launch System configuration. So we will see what happens. You're right that Artemis 2, the stack is currently back in the vehicle assembly building for checks on the upper stage. That's the second stage that will actually push the spacecraft into a lunar trajectory. There were issues with the helium mechanism for that upper stage. You might remember we did talk about that before. That's now being fixed, and we have a date no sooner than April the 6th for a launch of Artemis 2. So we'll look out for that. But yes, a major change in the Artemis strategy, which makes a lot of sense.
Yeah, I think it does. And copying a successful series like the Apollo missions, notwithstanding what happened to Apollo 13, but that was unforeseen. It was just a quirk, really. And everyone got home. But what I find interesting is those Apollo missions went back to back to back to back to back really fast. These ones seem to be much more elongated in their mission dates, don't they?
They do, and that's partly because the technology is now far more complex, because these missions are not just to achieve boots on the ground. It's all about setting up science, a kind of almost permanent presence on the moon. The ultimate schedule, again, this came out of the recent press releases and press conferences. The ultimate schedule is one Artemis mission per year once the first lunar landing has taken place. There'll be one a year. Now, that is much slower than the Apollo cadence. They were one every few months. I think so. Apollo 11 was July. Apollo 12 was November. Can't remember when Apollo 13 was, but you get the intervals were a few months rather than a few years.
Yeah.
I guess another reason for not just the scientific reasons for making it a spacing of 1 year, but that each of these is a very expensive venture. I've seen a figure quoted of $4 billion per launch for an Artemis mission, which is eye-watering. That's right.
Yeah. Did they hit you up for a loan for it? Yeah.
I think, I could probably muster a few dollars there.
Yeah, it's funny when you talk about the advances in technology, because I'm holding my mobile phone in my hand right now. It's got a hell of a lot more computer power than the computer on Apollo 11.
So that's right. Sadly, it's also invisible because of your background.
Is that better?
No.
Yeah.
It just disappears.
I think you know what it looks like.
You know what it looks like. That's right. Yeah. But you're absolutely right. Yes.
It's quite amazing. Not many people probably realise they're packing a lot more power than the Apollo missions carried. So, yeah, it's all in your pocket. If you'd like to read about the latest in regard to the Artemis missions, you can do that at the universetoday.com website, but NASA will have it on their website and many others as well. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
That's agreement, is that? Jordy, for goodness sake, I'm really sorry. This is what he does, is he gets very enthusiastic. Hang on a minute.
Space Nuts.
Oh, dear.
Drives me mad, honestly. It drives me mad.
I love it. I really do. To our next story, this could be the title of a science fiction novel, The Brain in Space. We're talking about a very strange nebula that looks like a brain inside a clear sphere. And this is the consequence of a star that's kind of shed its outer layers and created this quite bizarre looking nebula called PMR1.
Indeed, that's right. I very much liked the headline from space.com covering this story, which is James Webb Space Telescope performs brain surgery on mysterious exposed cranium nebula, which I think sums it up pretty well.
That's a good one.
Yeah, it's great. It's basically a highly evolved star, by which I mean a star that's getting near the end of its life. It's thrown off some of the layers of its outer envelope. And what we've seen from the James Webb is images which are taken in the near infrared and in the mid infrared. And so we get two quite different views of this thing that does look, for all the world, like an X-ray inside somebody's head. You can see the outline of the skull and a lot of funny stuff going on inside.
It really does look that way, doesn't it? Like somebody
does
put a brain in a goldfish bowl and chuck that up in the air.
Yes, that's right, with a few stars in the background. Yeah. It's a little bit close to home for me, actually, because the object's technical formal name is PMR1, and it was discovered originally by astronomers using the telescope, one of the telescopes I was astronomer in charge of, the 1.2 meter UK Schmidt telescope, back in the late 1990s. And three of my close colleagues were involved with this program: Quentin Parker, David Morgan, and Ken Russell. And their names are Parker, Morgan, and Russell, and that is why this is called PMR1. It was the first object that was discovered under a program actually really masterminded by Quentin Parker, an old friend who's now a professor in the University of Hong Kong. He had a mission to photograph the sky, because back in those days we were still using photography on the Schmidt telescope, using what we call a narrowband filter that just picked out the light of excited hydrogen, something called an H1 filter or an H-alpha filter. And so the telescope used this filter to survey the night sky, and many interesting objects were revealed, of which the first one in the particular program that he collaborated with David Morgan and Ken Russell was concerned, PMR1. That's the object we're talking about now. Now, we never saw it. With the Schmidt telescope, that was just a faint glowing blob. But with the James Webb, we see this extraordinarily detailed image. So that the history is that it was discovered in the late 1990s on the Schmidt telescope. The Spitzer Space Telescope, which was a kind of forerunner of the James Webb telescope, it's an infrared telescope, a NASA infrared observatory. When they looked at PMR1, that was when this curious appearance led to its unofficial name of the Exposed Cranium Nebula. But the James Webb has taken that a step further with these latest observations, which are really quite remarkable. And you do get a very strong impression of the three-dimensional view of this ball of, not so much a ball, it's a kind of elongated, almost like an oval football, elongated sphere of gas with a whole lot of stuff going on inside it. And what we've got is an ancient star, which is casting off its outer layers. There is a class of stars called Wolf-Rayet stars, named after two astronomers, I think, Doctors Wolf and Rayet, I think that's right, thinking back. And they are really ancient stars, massive stars that are getting near the end of their lives, and basically they have winds of radiation which are blowing away their outer envelopes, and form this nebula. And eventually they may turn into a supernova, an exploding star. So we understand, though, from the research that's been carried out with this, that whether it is a Wolf-Rayet star in the middle of PMR1 or something else, we don't know. That's going to be absolutely at the very center of that brain-like nebula inside the exposed cranium.
Yeah, I'm gathering that seeing something like this is very unusual. It doesn't look like the kind of nebula you'd normally see photographed. It's got uniformity for a start, and it's and you can see the explosive effect radiating out. It just happens to look like a brain.
Yes, that's right. That hydrogen alpha survey that I mentioned that Quentin Parker and colleagues were engaged in, I'm pretty sure I took some of the photographs for it as well back in the day, because I was still a working astronomer then when I was astronomer in charge. I think that one of the main things that program did was reveal a very large number of so-called planetary nebulae. So a planetary nebula is a cloud of gas that's usually has circular symmetry, which is why it looks like a planet. And it was William Herschel who gave them the name of planetary nebula. The most famous ones are the Ring Nebula in the northern hemisphere and the Helix Nebula down in the south. But this thing might actually in the end turn out to be a planetary nebula, which is an old star that's cast off its outer layers, and the central core of the star has turned into what we call a white dwarf, something about the size of the Earth, but with very high mass. Mass of a star, and those white dwarfs are very hot, and they're what excite the gas into glowing. But it's not clear whether this object is actually a white dwarf or one of these Wolf-Rayet stars that I was just talking about.
Yeah. I think we've probably got a bit of a pareidolia effect here, because we've just looked at it and gone, "Oh, that's a brain."
It's a brain. Yeah, that's right. Yeah, it's definitely pareidolia. Yeah.
When we were out on the river in Borneo, what they told us was it's chock full of saltwater crocodiles, because every time we saw a log,
yes,
that's the thing you thought it was.
Oh, it's a crocodile. Yes.
Yeah. Yeah. I think when we saw that 40-meter crocodile surging down the river, we were all panicking a bit. Turned out to be a tree. But
well, the branches gave it away, did they?
Yes. Well, no, it didn't have any. That's what really made it weird. But,
like a crocodile. Yeah.
Well, because we had all that monsoon rain while we were there, and the river was flooded. And this is a river 560 kilometres long, and about where we were 200 or 300 metres wide. It was massive. Well, and the water was flowing very fast. It was quite scary, actually. But it is one of those weird effects. We try to humanize everything we see, and you look at something and think crocodile. No, actually, no, that's a log. And here we are looking at a brain in space, which is some kind of nebula. Trying to figure out what kind and how it all happened. But you can read about that at the esaweb.org website if you want to check it out. Amazing images they are too. This is Space Nuts with Andrew Dunkley and Fred Watson.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Space Nuts.
In the past, Fred, we've had questions from the audience about the center of our galaxy, and it's not easy to answer because we can't see it. It's all shrouded in dust. Although you and I have discussed what it would be like on Earth if there was no dust, and the light would be so much different for us. So things could have turned out a different way had that dust not been there. But yes, it's shrouded. But there are ways to look, and they've just published a finding, thanks to a couple of the great telescopes on Earth, of what the center of our galaxy is like. They've mapped a massive section of it in significant detail.
That is correct. And I might just preface this discussion by noting that in terms of personnel, there is a close connection with what we've just been talking about, the UK Schmidt telescope, because one of my former colleagues at the UK Schmidt telescope Dr. Andy Longmore. I worked with him at the Royal Observatory, Edinburgh. He's still based in Edinburgh, but he and his wife, Marie, were actually visiting us here in Australia at the beginning of this year. So I went up to Newcastle to see them. And it's their son that is the lead author on the paper that has just mapped the centre of the galaxy, which is very nice. It's a lovely connection. So Steve Longmore, their son, like father, like son, he's turned into an astronomer and very capable because he has led this major survey, which is called ACES. ACES is an acronym for ALMA CMZ Exploration Survey, and the CMZ, if I remember rightly, is the central central molecular zone of the galaxy, where molecules lurk around the black hole at the center of the galaxy. So these observations have been principally done by, as you said, it's been done by some of the great telescopes. One of them is ALMA itself, the Atacama Large Millimeter Submillimeter Array, that has basically formed images of the whole of the region around the center of our galaxy. And it's a very, very detailed image. It's a mosaic, basically, that's been built up. And the great thing about ALMA is that you can tune it in to the various chemical molecules, all of which emit their radio frequencies at different wavelengths. So it's like having a radio spectrum of every point in the center of our galaxy, which means that you can build up images showing how these molecules behave around the center of the galaxy. So it really is an extraordinary piece of work. With a lot of detail, a great deal of information about both the turbulence and the chemistry that's taking place around the center of our galaxy. There's a very extensive article about it on the brighter side of science, a brighter side of news. It's got some great images and a lot of details about what has been found. I'm looking for a quote which came from one of the scientists, which really describes very cogently what they've done. In fact, Steve Longmore himself is saying the CMZ, or CMZ we would call it, but I'm Americanizing it because that's... Yeah, Atacama Large Millimeter Array has got a strong US contingent as well as other international users. The CMZ hosts some of the most massive stars known in our galaxy. Many of these stars live fast and die young, and they end in supernova explosions and in some cases what we call hypernovae, very, very intense supernovae. Let me just find some other words that I was looking for, because the extraordinary thing is just how turbulent this region is. The fact that we've got packed into that region around the center of our galaxy, we've got the turbulence of gas moving under the gravitational influence of a black hole. You've got the gravity of the black hole. You've got intense magnetic fields. You've got outflows from these giant stars. And all of this is coming together to make a very complex region of space, which basically is what has been revealed by this new image. It is quite extraordinary.
It is rather, and I'm just reading some of the data and, the description. They've given lists a radius of 6.1 parsecs with an expansion velocity of 21 kilometres a second. Like you said, it's a pretty busy neighbourhood.
Yes, about 650 light years across. So really quite a large area. And you're right, actually, the other telescope that was involved, sorry, I didn't mention that, is the European Southern Observatory's Vista telescope, which is one that is also at Cerro Paranal near the VLT. Vista was a telescope built actually by the Brits and used by them as their buy-in to the European Southern Observatory.
It's a really great article. I like the way they've got those different images of the various chemical makeups of the section, right. And they've overlapped them all to create one image. But you can look at it from several viewpoints, really, and helps you to understand what's going on in there, which we've been trying to figure out for a long time, Fred.
Yeah, that's right. I mean, again, harping back to my time at the Royal Observatory in Edinburgh, my work was actually on, my research was about stars in the galactic center region, and we couldn't see the galactic centers because it's hidden from us by dust, and a lot of these stars were visible through thick layers of dust. That's all penetrated, of course, with infrared telescopes, and that's why, and by millimeter wave telescopes too. That's why you can reveal all these fairly complex molecules that have been found. Really quite a remarkable, exactly as you've said, it's a great article, gives you a good idea of just what's going on in the centre of our galaxy.
Somebody's going to ask, so I'll ask on their behalf, why couldn't James Webb have done this?
A lot of it's to do with field of view. The fact that you've got a huge area here, you need the coverage of what we would call a survey telescope, which the James Webb isn't. It homes in on fine points of detail. And the other thing is the James Webb would give you a different set of chemical constituents because you're looking at different wave bands. So these are the ACES project, the one I just mentioned, which uses ALMA as its main instrument. That's looking in the submillimeter wave region. And so you see that's sensitive to different molecules from what you get in the infrared. So it's really, it's a really neat piece of work that's been done by the right telescope by the look of it, and the right group of people.
Indeed, yes, fantastic. If you want to read all about it, you can do so by finding the paper. Just do a search for ACES Overview Paper, or you can read the fabulous article at thebrighterside.news. We're just about done, Fred. Thank you very much.
It's a pleasure. That went extremely quickly, Andrew.
It has been lately. I don't know why. Maybe we're finally getting more efficient.
No. So only adequate, not efficient.
I think it's because Geordie didn't actually play up too much.
That's right. It's because his sister's there holding him down.
Yeah, I bet she is. Sisters do that. Thanks, Fred. We'll catch you very, very soon.
Sounds great. Thanks, Andrew.
Professor Fred Watson, astronomer at large. Don't forget to visit us online while you're listening to the podcast, maybe spacenutspodcast.com or spacenuts.io, and have a look around, visit the shop, maybe become a supporter, leave a review on your platform wherever you listen to us, and don't forget you can send us notes and information and questions on the Ask Me Anything tab at the top, AMA. And thanks to Hugh in the studio. Now, Hugh couldn't be with us today. Apparently he heard about this mapping of the centre of the galaxy and put the coordinates in his car GPS, and he hasn't been seen since. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.